Today we are going to discuss about Biot Savarat Law. We know that the current carrying wire produces a magnetic field around them. How do we calculate the strength of a magnetic field in a particular point? We can calculate it by using Biot Savarat Law. This law is analogous to Coulomb's law in electrostatics. To use this law, we can consider a current I flowing through a curved wire of length L. Now, let us imagine a tiny element of this wire having length dl carrying a current I. The current through this element is always directed along tangent to the wire. That means the direction of dl is same as that of the current I. Now, we want to calculate the strength of a magnetic field at a random point over here or a particular point P. Let R be the distance from the point P to this element dl. Biot Savarat law basically says that the strength of the magnetic field at this point P can be written as dB vector. That is, dB is the magnetic induction at P due to this tiny element dl is equal to mu naught divided by 4 pi. Mu naught is a constant, that is permeability of free space. I dl vector cross R unit vector divided by R squared. This is the vector form of Biot Savarat law. We can also express in scalar form, that is the magnitude of magnetic induction dB is equal to mu naught divided by 4 pi I divided by R squared. In vector form, we know that in vector product, we know that dl vector cross R unit vector can be written as dl or sin theta. Here dl vector, that is the magnitude of dl vector is dl. The magnitude of R unit vector is 1. So dl into 1 into sin theta. Here theta is the angle between dl and R. Here dl is along the direction of the current I and R unit vector is along the direction of R. So we can write sin theta. So dB equal to mu naught divided by 4 pi I dl sin theta divided by R squared. It is the scalar form of Biot Savarat law, or we can say the magnitude of magnetic induction at the point P due to the current element dl. So we can also see that the magnetic field depends upon the strength of the current I, which means that the moving charge produces magnetic field. That is, higher current means more moving charge per second. So we can have more magnetic field. And also dB depends upon dl, that is the length of the current element. If we take longer current element, then we have more moving charges. So we have more magnetic field, or we can say that the magnetic field will be larger. Here dB is also inversely proportional to R squared. If the distance R increases, the strength of the magnetic field decreases.